Module 5 will cover designing for scale and resiliency. Chris, this is really about one of the strengths of Azure as the data platform capabilities that we have there. It gives you that opportunity to scale on demand, gives you that opportunity to also think about resiliency differently than what you're doing in an on-premises environment. So,
yeah, it's the bit that the accountants love, because you're not having to pay for all that scale in advance of using it.
Yeah.
And I only know that because my father's an accountant, so and he's been through this process, which is why he likes the cloud so much, because he only pays what he needs to pay for.
Okay.
So designing for scale and resiliency, we're going to look at it from a technical perspective, design perspective. And in these lessons, we'll talk about scaling systems, and that is its key strength, right? It is absolutely its key strength.
When I look at these, when I do look at these lesson objectives, I go scaling systems. Okay, man, networking, storage, performance bottlenecks, high availability, disaster recovery, backup and restore.
We've always had the hardest job in the world of data.
Yes, but it honestly makes me feel, is that not a data management DBA task? Because looking at these lesson objectives, that's kind of how I feel about it. And I go, that's easy. I mean, as a trainer, I don't need to prep for any of that. This is dynamic management views. This is always on availability groups. This is backup and restore.
It is from a data perspective. It is if you're doing it from a data perspective, but there are a lot of other things in the cloud that you can use as well to monitor it. And I just go back to the point, right? You may not necessarily be the one implementing it, right? But you have to be aware of it from a design perspective.
But we're looking at this from a cloud perspective. We're not
correct.
We're not getting into the granularity, but I'm going to look on, let's say, hey, identifying performance bottlenecks. I'm going to be drilling down in queries that don't use indexes or index optimization.
No, we're not going into that depth at all.
Okay.
At the end of the day, the nature of the DP-200 and the DP-201 exam isn't to go that deep down. It's basically taking like a bird's eye view of all the technologies from an implementation and a design perspective.
Because that could be more like a data management specialty administration.
Exactly.
Okay.
So scaling systems, right? Talk about scaling up and scaling down. You should be very familiar with this, because scaling up and scaling down a single system is usually up in the memory, up in the CPU, or so forth, right?
And there we go with containers and everything, and you lost me right there.
Which is why I want you to talk about scaling up and down first, right? Because you understand that in the context of a single virtual machine.
Yeah.
You can adjust it with the memory, you can adjust it with the vCores, Are scaling in and out. If you've done DP-200, you know that when you change that sliding scale on DWUs, that's scaling out to more compute nodes to actually process the data.
Okay.
However, we are entering a new world of serverless computing, and this is being used more and more.
Yep.
And there may be references to it in the exam as well.
Yep.
So we're just bringing to your attention that scaling systems may be done by scaling up and down. It may be done by scaling in and out.
Okay, fair point.
But you can scale in and out using containers. And containers... Go on, sorry.
Yeah, I'm thinking prep materials, right? It's like that again would probably, I want to look at some of the assets that sit on Learn, specifically around Kubernetes.
Exactly. So we do have materials on Learn that cover these areas. Basically, you just got to see this as a level of abstraction above virtual machines, right? And containers give you the ability to run applications, or where I see it being used most is actually in data science. I see containerization and serverless computing helping to scale out the compute requirements of data science solutions. And that's usually done through either Azure Container Instances, which is basically a serverless approach that allows you to create and execute containers on demand. And you can use Azure Kubernetes that allows you to manage essentially that infrastructure so that you can, manage the worker nodes that host those containers, right? So at the level of this exam, you're not going to be going into this at all. It's there for your knowledge moving forward.
Okay.
So when it comes to optimizing network performance, I don't expect you to be networking experts. It's a little bit of common sense. We have many data centers across the world. at the end of the day, you got to think about where you place your resources. If you place one resource in Western Europe and another resource in Australia, and they are dependent on each other, you're going to have latency. So you need to think about, do I co-locate resources around the world, or within the same region, or in the same data center? But also, you've got to think about the latency impact with the user out in the world to the Azure.
So one of the key aspects there is also making sure you bring your data closer to the user.
Yes.
That could be done with things like geo-replication, multi-master.
Exactly.
But also could be done with a CDN, or even setting up an express route to bring the on-premises data closer to Azure.
Precisely, exactly. And it's about understanding the different options available to you.
Fair point. What's next?
So with regards to storage performance, what we're talking about here is virtual machine storage performance. So, you know, making the selection, if you've got a SQL server running on a virtual machine, you've got a different choice of storage, right? You can use standard storage, you can use premium storage, right? Are you making use of caching, right? Like the analysis services in front of SQL Data Warehouse. And what about the storage performance for your applications? Because it's all well and good considering it for your databases, but if you're not doing it for your applications as well, then you basically... You're only as strong as your weakest link, so you might use CDN there. But there's also something called polyglot persistence, where you've got, it's basically a term that refers to a hybrid approach to different data platform storage mechanisms for maybe storing your hot data versus your cold data and being able to switch between them. And you'll build that into your architecture design to optimize the storage performance that you have. What about identifying performance bottlenecks, right? It's all well and good architecting for this, but also you've got to think about detecting it in the first place.
So this really goes into the monitoring capabilities on Azure that we have. They're like things like log analytics, Azure monitors.
Exactly.
How do you do that kind of performance management?
Exactly. And the first of all is that you need to understand the importance of requirements. You might have known this in the past as service level agreements, right? You'll have done it through baselining. If you understand what is deemed acceptable, then you can start to identify bottlenecks, right? And that helps you with your DevOps and understanding your application performance as well. So the tools that you can use to help you with this is Azure Monitor. That provides a general overview of infrastructure level logs and monitoring for most of the Azure services. Within that, you can use Log Analytics, and that can surface itself through Azure Monitor, where you can look into the logs and get specific information. And don't forget application insights as well.
Correct.
That can capture really useful information about the behavior of your applications, how they interact with your data platform systems. All of this will be incorporated within your design as to the level of monitoring you will provide at a general level and at a more in-depth level. High availability. What's your service level agreement in this area, right? What is deemed to be highly available and when for some organizations.
And that goes into really understanding, like, hey, what are the high availability capabilities of each of the services?
It does, because at the end of the day, if you understand what your availability requirements is for the business, and you understand the capabilities of each of the data platform technologies, then you can evaluate the capabilities against that given requirement.
Yeah, this is very straightforward.
Exactly. Disaster recovery, make sure you have a plan. It should be a risk assessment. What inventory are you dealing with? What are your recovery objectives? I mean, we talk about having detailed recovery steps. You probably won't do that within a design aspect. You're only going at the high level, but it's something to bear in mind. Design your architectures with disaster recovery in mind, being able to recover data. Maybe you might use services that you wouldn't think of, like Azure Site Recovery. Or there may be a service-specific feature, such as the geo backups within Azure SQL Data Warehouse, or Cosmos DB backups.
Makes sense.
Make sure you test it as well. A disaster recovery is only as good as your last test. Backup and restore. Establish what your requirements are. Look at the Azure backup and restore capabilities.
Which pretty much goes into, hey, what's available, how does it get performed?
Yeah, exactly.
I think we covered some of that in the DP-200 implementation.
That's right. DP-200 does cover this in depth. So if you've done the DP-200, they'll have that information already.
Now you've taken it into the design.
Correct. And verify the backups and test that restore procedure. So from a lab perspective, what we're doing is we're focusing on some of the key aspects that we're looking at there for scale and resiliency. And basically, we're looking at adjusting workloads by scaling, looking at optimized storage for database performance, designing highly available solutions, and look at how we bring in disaster recovery into our architectures.
Cool.
So using the case study, right, what you're going to do is you're basically going to provide a short report to the board of directors that addresses their concerns about business continuity. Now, within business continuity, we're looking at that from all the topics that we've just discussed. Availability, disaster recovery, and then optimizing for performance and also for
And this is so important because this is really where your design of the overall solution stands and falls, right? I mean, you need to keep that in mind, this high availability and scale at the beginning.
Yeah, absolutely. I like the way you say it's where it stands and falls, because at the end of the day, it's all well and good having a wonderful architecture that can deliver the functional requirements of a solution. But what we're talking about here is non-functional requirements. It's stuff that not necessarily the board people would think of, but you need to have that in place, because if you don't have availability and disaster recovery, it will fall.
And so similar to the other labs, and we have a review section.
Yeah, exactly. So the review section is like, you know, give the opportunity to the groups to present the findings, right, for the reports they're going to do. And has anything been missed? So we're taking a different perspective here, not focusing on what they've come up with, but looking at what they've missed. Was there any debate in any of the options that are choosing? There will be. Are there technologies that could not provide any availability in disaster recovery? This is a good question, right? Because, you know, someone might go for Cosmos DB, but we know that Cosmos DB only keeps the last 2 backups, and backups are only taken every 4 hours. If the business requirements, if there's a conflict with that, it may not be the right one to choose. And finally, which availability of disaster recovery options are of importance to your organisation? It's about bringing it back to them, applying it to their environments so it reinforces the learning.
Fair enough.
You'll then go through the module review, recapping off what you did, and this is a really useful resource to have back at work,
The checklist?
Yeah, for both the resilience and the scalability checklists. I recommend that you take a look at that before you go into the classroom, because they'll probably use it once they've seen it.
Perfect.
And that wraps up this module.
Yeah. Thanks. Let's get on to the next module then.
Sure.